Very good afternoon. Today we are going to see about load curves and selection of generating units. So already we have seen how to draw the load curves, that is load curve and load duration curve. And among from the load curves, so now we are going to see how to select the generating units based on the load patterns, load based on the load how it is varying, no? Based on the load patterns, how we are going to select the generating units that we are going to see now. If you see, the load on the power station is not constant, it is varies from time to time. Even it varies from minute by minute, it might be varying, even second by second also it might be varying. Then obviously a single generating unit will not be able to be an economical proportion to meet out this varying load. So if you are having only one generators, and with that generators, if you manage with that varying load, it is not possible, and also it will not be economical also. Why? Because why it is not economical in the sense, if the generating unit, okay, suddenly if the load is varying, so we need to increase the generation. So by the time, we need to spend more on the resources, more on the, if you choose the thermal generating unit, you need to spend more on the resources, so that your cost will go side. So it is not economically proportionate also. So this is because a single unit will have poor efficiency during the periods of light loads on the power system. Okay, so particularly if you rely on one single unit, it will be having some poor efficiency. Therefore, in practice, a number of units of generating unit with different sizes is being installed in a power station. There might be not only one generating unit to meet out the demand. There might be a series of generation operating in the parallel, like installed, and it is operating in the parallel, so that it meet out the demand. The selection of number and size of unit is decided from the annual load curve. Based on the annual load curve, how, say today's load, if we want to predict, means we need to take out the like last year's load curve, and we have to analyze last year load curve. We have to analyze how it is varying, like today what is the maximum load. Based on that, we have to generate based on the annual load curve. We have to generate the number and size of generating unit are selected in such a way that the correctly it has to fit the station load curve also. So the size of the number and size of generating unit are selected in such a way that correctly we have to fit the station load curve. So particular station load curve also we have to fit it. So once this underlying principle is adhered to it, it is possible to operate the generating unit near to the point of maximum efficiency. So that maximum efficiency also we shall meet out. So in this in this load curve, if you see the load curve, so this is for like 24 hours, 24 hours of period, it has been plotted. So this principle of selection of number and sizes of generating units with the help of load curve is illustrated in this figure. Okay, so in this annual load curve of the station is shown. It is clear from the curve that the load on the station has wide variations. Okay, so it has wide variation, it is not being constant. We can't able to tell like this is the base load, like that. It is varying like anything. And also it is clearly seen from the curve that load on the station has wide variation. That is minimum load being from 50 kilowatt. here this load is given in the kilowatt. In this axis time is given in hours. So depends on the load. This variation also will be happening. Depends on the timings. This load also will be happening. It is hard needs that any mention use of single unit to meet out this varying load will be highly uneconomical. So highly, that is also highly uneconomical. So this the total plant capacity is divided into several generating units of different sizes to fit in the load curve. So if you see like the total plant capacity is divided into several generating units to fit in the to the load curve. Okay, so this is illustrated in the figure where the plant capacity is divided into three generating units. Say for example, this plant for meeting out this demand, we are choosing three plants. That is generating unit one, generating unit two, and three. So that is shown in this second figure, one, two, and three. Okay, this shows this color shows the capacity being used. Okay, unit capacity being used. Three units employed having different capacities and used according to the demand on the station. In this case, the operation schedule are given below. That is time versus unit in the operation. So if you see the timings, like 12 midnight to 7 a.m. 12 midnight to 7 a.m. Unit 1, 12 midnight to 7 a.m. So where is 12 midnight? Yeah, this is 12 midnight to 7 a.m. Up to here. So unit 1 is it will be in the operation. After that, 7 a.m. to 12 noon. 7 a.m. to 12 noon. Unit 2 also started, so that both units 1 and 2 are in the operation. Okay, after 7 a.m. to 12 noon, after 7 a.m. to 12 noon, you see that unit 2 also started in the operation, so that both units 1 and 2, 1 and 2 is in the operation to meet out the demand from 7 a.m. to 12 noon. Next, from 12 noon to 2 p.m. 12 noon to 2 p.m. Yeah, from here 12 noon to 2 p.m. Okay, so unit 2 alone is stopped and unit 1 operates. Unit 2 alone is stopped, unit 1 operates. So from 2 p.m. to 5 p.m. 2 p.m. to 5 p.m. Here if you see 2 p.m. to 5 p.m. 2 p.m. to 5 p.m. Unit 2 is again started. Now units 1 and 2 are in operation. So unit 2 is again started. So unit 2 and 1 is in operation. Next, 5 p.m. to 10:30, 5 p.m. to here around here, 5 p.m. to around 10:30. If you see like 1, 2, and 3 are put into the operation. So this three generating units, so unit 1, 2, and 3 are also put into the operation. Next, 5 p.m. to 10:30 p.m. 5 p.m. to 10:30 p.m. 5 p.m. to 10:30 p.m. You see 1, 2, and 3 are put into the operation. Then 10:30 to 12 midnight. 10:30 to 12 midnight. 1 and 2 will be in the operation. 10:30 to 12 p.m. 1 and 3 will be in the operation to meet out the demand. So this is the one simple example. Okay, this may be varying. This may be varying. Depends on the demand also. Thus, by selecting the proper size of generating units, also made to operate near the maximum efficiency. This results in overall reduction in the cost of the production of the electrical energy. So these are the important points in the selection of the generating units. So while making the selection of number and size of the generating units, the following points should be keep in the view. The first thing is that number and size of units also should be selected such that approximately it will fit the annual load curve of the particular station. So one particular station alone, will be kept in the one particular station alone taken as an example. In that, number and size of unit also selected such that it should be selected such that approximately it should fit the annual load curve of the that particular station also. Next thing is that the unit should be preferably of different capacities to meet out the load requirements. So it should be of different capacities. So to meet out the load requirements, although use of identical units saves the cost, then they often do not meet the load requirement. Okay. So next is that the capacity of the plant should be made 15 percentage to 20 percentage more than the maximum demand. More than So whatever the maximum demand, say for example 1000 megawatts is the maximum demand, so we have to make 15 to 20 percentage. So 1200 megawatt we have to generate so that it meets the future load demand requirements also. Immediately the load may be varying also. By that time we have to generate more amount, that is 15 percentage or 20 percentage, so that the future load requirements also it might be satisfied. Then there should be the spare generating unit so that repairs and overhauling of working units can be carried out. So spare generating unit also should be there so that if any overhauling of the working unit will be there, simply like that you can simply use that spare generating unit also. Next is the next in the sense, the tendency is to select a large number of units of smaller capacity in order to fit the load curve very accurately also should be avoided. And also this is because investment cost per kilometer capacity increases as the size of the unit decreases. Okay. So that also we have to taken care of. That is the tendency to select large number of units of smaller capacity in order to fit the total load curve very accurately should be avoided. This is because the investment cost per kilowatt of capacity increases as the size of the unit decreases. Okay, so that also we have to taken care of. Next, coming to the selection and number of size of generating unit, assuming the power factor of the machines to be zero point 0.8, the output of the generating units available will be of this is of like this very small loads, that is of 8 16 20 and 24 megawatt. So however this can be several possibilities. However, while selecting the size and size and number of units, it has to be borne in the mind, like one has to set the highest capacity should be kept in the standby generating unit. Next, the unit should be meet out the maximum demand. So if you see in this load curve, okay, from this load curve we have to meet out the maximum demand. Okay. So with that the unit should meet the total maximum demand 70 megawatt on the station. So there should not be the overall economy. Okay. So overall economy also should be maintained by in this scenario. So keeping in this view the above facts, four sets of 24 megawatt, okay, 24 megawatt each may be chosen. Okay. 24 megawatt each may be chosen. Three sets will meet out the total the maximum demand of 70 megawatt. One unit will save the standby unit. Okay. So this is also we have to taken care of. Next is operation schedule. Operation schedule, like set one will run for 24 hours, then set two run for 8 hours to midnight, 8 hours to midnight, 12 like 11 59 midnight. And after that, set 3 will run from 11 hours. Set 3 will run from 11 hours to 16 hours, then again from 19 hours to 22 hours. So depends on the demand, you have to choose the set 1, 2 and 3. Next, coming to the base load and peak load. Coming to the base load and peak load. Okay, so what is meant by base load and peak load? Like how to meet out the load curve on the power station. So these are the two types of load. This load parts is being divided into two types. That is, one is base load and another one is peak load. So what is meant by base load means unvarying load which occur almost whole day on the station is known as base load. Okay, so unvarying load which occurs almost the whole day. So whole day of the power station it has to meet up. So that is called the base load. So that is the unvarying load which occurs almost the whole day. So if you see here, so this is the load pattern. So load pattern it is varying. So one base there will be some base load. It might be happening for almost the whole day alone. So if you see in this figure, so this 20 megawatt is happening almost all the whole 24 hours. So if you choose a 20 megawatt generating unit, that power generating unit has to be operated for whole 24 hours. Okay, so for peak hours alone, we have to choose some other generating unit so that it will meet out the demand. Okay, so in this figure, it is clear from 20 megawatt of the load is supplied by the station at all the times of day and night throughout 24 hours. 24 hours. Therefore, 20 megawatt is the base load of the station. So 20 megawatt is the base load of the station. As the base load on the station is almost constant nature, therefore it is suitably supplied without facing the problems of the variable load. Next, coming to the peak load, the various peak demands of the load over and above the base load of the station is known as peak load. Okay, so here if you see, yeah, this is the peak load. So this is the after the base load. So it is moving now. That is called peak load. That is the various peak demands of the load over and above the base load. So over and above the base load is known as peak load. So it is clear that peak load of the load exceeding the base load. So these peak demands on the station generally form a small part of the total load, may occur throughout the day. So next is method of meeting out the load. So how the method? What are the method of the meeting out the two loads? So if you see here, okay. So if you see here, these are the load patterns, load curves that we have taken for 24 hours. Okay. So if you see like here, this 20 megawatt, this 20 megawatt is the base load that is always happening throughout the day. So this 20 megawatt, what we have to do, here what we done is we have chosen this hydro power station for we have chosen hydro power station for generating 20 megawatt for 24 hours. So like peak load alone we are going for choosing the choosing this steam generating units. Okay, this is high flow day means the hydro generation is maximum, so that we are maximum utilized with the hydro power station alone. So if you see this low flow day where the hydro is very less. Okay, hydro from the dam, the level of the dam, okay, water in the dam is very less, that is called low flow day. In that low flow day, okay, so now like a majority, like the base we have taken as steam generating units. Okay, so peak we are going for hydropower generating units. So the interconnection of steam and hydro. Okay, so this is called the steam and hydro combination, like a steam and hydro interconnected power plants. In that, the steam and hydro power plants is interconnected, so to meet out the demand, that when the water is available sufficient quantity, as in summer and rainy season, the hydroelectric power plant is used to carry the base load, and the steam power plant supplies the peak load, as shown in this figure. Okay, so this is called the load division on the hydro and steam power plant. And if you see, like, total load on the power station consists of two parts, that is base load and peak load. In order to achieve the overall efficiency, the best method to meet the total load, is to interconnect two different power station. The more efficient plant used to supply the base load is known as base load power station, and less efficient plant used to supply peak loads, that is known as peak load power station. There is no hard and fast rule for selection of base load and as well as peak load station, as it would depends on the particular situation. For example, both the hydroelectric and steam are quite efficient and can be used as the base load and as well as the peak load station to meet out the particular load